Lesson 1-6 is about solving and graphing inequalities on a number line. So by the time we finish this lesson, you should be able to answer what are some important things to remember when graphing inequalities. Okay, first you need to know what a solution of an inequality is. A solution of an inequality has to make the inequality true when you plug the number in for the variable. So for example, we're going to try this. Is 4 a solution to the inequality below? And we have 6x plus 2 is greater than 20. Now, some of you guys may have trouble remembering your greater than, less than symbols. So real quick, I just want to go over a quick way to know this. If it points to the right like this, if the arrow points to the right, then it is greater than, because all the positive numbers are to the right. If it points to the left like this, it is less than. So left, less than. That's easy to remember. Okay, so um, first what we're going to do is to figure out if 4 is a solution, we have to plug in 4 for x to see if it works. So if we plug in 4 for x, we have 6 times 4 plus 2 is greater than 20. And if we work that out, 6 times 4 is 24, plus 2 would be 26, is greater than 20. And that is true. So 4 would be a solution to that inequality. Okay, now when we are graphing inequalities, I've got some things here for you to remember. And I'm going to kind of move it over just a little bit so you can read it. Um, so here are the steps for graphing inequalities on a number line, and we'll practice this. So first you have to find the number on a number line. So if it says that um, x is greater than 4, then you would find 4 on the number line. Now, if the inequality is less than or greater than, where it does not have the little bar underneath it, then that would be an open dot. So if it looks like this or this, you're going to put an open dot, okay? One of these two. Now, if it is greater than or less than or equal to with the bar underneath, then you're going to have a closed dot on the number because that means that it includes that number as a solution. The open dot means that it cannot include that number. And then finally you're going to draw an arrow in the direction of the inequality symbol to show the solution. So if it's greater than, it points to the right like this, then the arrow is going to point right to show greater than. If the inequality symbol points left and it's less than, then your arrow is going to point to the left. So let's go over that a little bit. So for instance, we're going to graph the inequality c is greater than negative 2. So we're going to show all the numbers that are greater than negative 2. So first, we have to find negative 2 on the number line. And then we have to decide if it's open dot or closed dot. Well, if we look, it does not have the bar underneath, so that means it is going to be an open dot on the negative 2. And then finally, you have to choose which direction your arrow goes. And you'll notice that your inequality points to the right because it's showing greater than. So our inequality should look like this. We put an open dot on the negative 2, and the arrow points to the right to show all the numbers that are greater than negative 2. Pretty simple. All right, let's do some examples. So let's try writing an inequality for each of these graphs. So first, if we look at number 1, we know it's going to have negative 4. And you can use whatever variable you want. You can use x, whatever, y, whatever. And then the arrow is showing less than negative 4. So we're actually going to go less than like this. It points to the left, so we make our sign point to the left. Pretty easy. And you can check your answers over here. We got it right. Okay, number 2 is on the 5, and it is a closed dot. So we have x and we have 5. And if it's a closed dot, that means that it's equal to underneath, so we have to do the bar. and the arrow is pointing to the left. So we have less than or equal to 5 because it's all the numbers less than 5. Okay, and then finally number 3, we can use x again, and we have -1, and it's a closed dot, so it's going to be equal to, and it points to the right. So we want our symbol to point to the right to show greater than, and then the bar underneath to show equal to. All right. Okay, now when you're solving inequalities, okay, you're going to solve inequalities just like you would solve if it had an equal sign right here. So you're going to solve them just like you would solve equations, same steps, and then just graph the solution. So if we have x plus 3 is less than 5, we're going to pretend that this is an equal sign right here. And so how would we get x by itself? Well, we would subtract 3 from both sides. And so then we come up with a solution, x is less than 2. Now we have to graph this on a number line. So you're going to draw a number line, and then you're going to find 2 on the number line, and you have to decide, is it an open dot or a closed dot? And it would be open because this does not have the bar underneath, and the arrow points to the left, so we would make sure that we have it pointing to the left. And I wrote the steps here for you in case you want to write those down. If you forget how you're supposed to solve an inequality, you can write those steps. So again, we put an open dot on the 2, and the arrow was pointing left to show it's less than 2. So any number less than 2, we could plug it in, it would work. Alright, let's try another one. So same thing, you're going to solve it like you would any normal equation. So if you want to get m by itself, you would add 6 to both sides. And then we get m is greater than 2. So again, we're going to draw our number line. We're going to find 2 on the number line. And then we have to decide, is it an open dot or a closed dot? Well, it's open because there's no bar underneath. And then it points to the right, so we're going to make our arrow point to the right. Now notice my number lines are already numbered here. I don't mind if you number these. You don't need to number every single thing unless you just want to, but you need to put this number, the 2's, you need to at least put those on your number lines. That way I know where you put the dot, whether it be opened or closed. So when you're doing a homework assignment, and I have number line paper that you guys can use so you don't have to draw these every time, make sure you at least put this value on the number line. Alright, now we're going to solve some inequalities that have variables on both sides of the inequality symbol. So it's just the same, again, as if you were using an equal sign. So first, because we have x's on both sides, we have to get them together on one side. So you need to cancel one of them out. It doesn't matter which one, but I preferably choose the smaller one because it makes us stay positive. So, but in this case, in the book, they did it with the bigger one, and it doesn't matter because you'll get the same answer either way. So if you subtract 7x from both sides, then you get negative 2x plus 2 is greater than negative 4. Okay? Well, from here, we would solve it again like a normal equation. If we want to get x by itself, we have to cancel out this 2. So we would subtract 2 from both sides, and then we end up with negative 2x is greater than negative 6. Okay, well, we still need to get x by itself. So we need to divide by negative 2 on both sides. Now here is something that you have to know when you're working with inequalities. If you divide by a negative, you must flip the inequality symbol. Okay, you might want to put that over here as a note. If you divide, or multiply for that matter, by a negative number, you must flip the sign. or the symbol, whichever one you choose to say. Okay, so in this case, we have to flip it over. And so now our symbol points to the left, if you notice. And so we get x is less than 3. Now, if you worked it out the other way, where you would subtract 5x instead, then your x's would be on this side. So what you need to do then is you would end up at the end with 3 is greater than x. Let's say you end up with your answer like that. If your answer is on the wrong side, like if x doesn't come first, you need to rewrite it before you graph it. Otherwise, it will be wrong. So if you have to rewrite your answer, you need to rewrite it with x first, flip your symbol back, and then put 3 on the other side. Because see, you always want 3 to be the larger number that the symbol is opening towards. So see, we get the same answer, but if you get it like this, you need to rewrite it before you graph it or you'll be confused. So if we graph it, we have 3. It would be an open dot because there's no bar underneath, and the symbol points to the left, so it's all the numbers less than 3. Okay, here's another example. And feel free to pause the video and try these on your own before I work them out so you can check and see if you did it correctly. So from here, we need to cancel out one of the x's. Doesn't matter which one. Okay, so if we cancel out this one, since it's a negative x, we would add x to both sides, or you can subtract this one. So they subtracted x from both sides, so these ones would cancel out here. And then, so they end up with 3 minus 2x is less than or equal to negative 9. And now I think the reason why they're doing it this way is because they're always gathering the x over to the left side so that x is always first. So when you're doing inequalities, you can do that if it helps you. So from here, we need to get x by itself, so we're going to subtract 3 from both sides because the 3 itself is positive. And then we end up with negative 2x is less than or equal to negative 12. And so to get x by itself, we have to divide by negative 2. And I hope you remembered to flip your sign because we divided by a negative number. So if you flip the sign over, you end up with x is greater than or equal to 6. And then we just have to graph that on the number line. So we would find 6 on the number line. We need to decide if it's going to be an open dot or a closed dot. And it would be closed because it has the bar underneath. And the arrow points to the right because it's greater than. So your answer should look something like this. And we can put the 6 underneath here. All right, one more page and then we're finished. The last thing we have is solving compound inequalities. And it says containing and. Now, and means when they're connected together. So this reads like negative 4 is less than r minus 5, and r minus 5 is less than or equal to negative 1. So we have like two symbols in our inequality, which is why it's called a compound inequality. So really, you have two different inequalities here. And so the first thing you need to do is rewrite them into two separate inequalities. So you have one where negative 4 is less than r minus 5. So we're going to write that one down first. And we have r minus 5 is less than or equal to negative 1. So you need to write that one separate. So separate it to where r minus 5 is included in both inequalities. Then you can go ahead and solve each one separately. So over here, if we add 5 to both sides to get r by itself, we get 1 is less than r. And remember, we need to rewrite that before we can graph it because r does not come first. So we need to rewrite it so r and then flip our sign is greater than 1. So that one's finished. Okay, then we can solve this one. So again, we're going to add 5 to both sides to get r by itself. So we end up with r is less than or equal to 4. And we need to graph these two solutions on the same number line because it's a compound inequality. So, and we're talking about the same letter r here. So we're going to put 1 on the number line and we're going to put 4 on the number line. And we need to decide at each one if it's an open dot or a closed dot. So on the 1, it would be open because there's no bar underneath. And on the 4, it would be closed because there is a bar underneath. And then this arrow would point right, and this arrow would point left. So what happens is they come together. And when they come together, you don't need to draw the arrows going past that. You just need to connect them. So anytime you have an inequality that's connected like this, the graph is going to be connected. So you know that as a hint, if you graphed it and they weren't connected, you did something wrong, or maybe you graphed this one incorrectly. So that's one way that you can check your answer for those. Now for inequalities that are compound that contain or, it looks like this example. So it'll say 4v plus 3 is less than negative 5, or negative 2v plus 7 is less than 1, and then they want us to graph the solutions. Well, basically, I like the or compound inequalities because they've already separated them for you. So basically, you just solve each of them separately, and then you graph the solutions together. So it's kind of nice because they already broke them apart. So we're going to solve both of our two inequalities separately. So first, if we want to get v by itself on this one, we need to subtract 3 from both sides. And then these cancel out, so we end up with 4v is less than negative 8. And then we have to divide by 4 to cancel that out. Now notice, I don't have to flip my sign this time because the number I'm dividing by is not negative. Even though this number is negative, that's okay. We just want to flip it if the number we're dividing by on the bottom is negative. So we end up with v is less than negative 2. And then over here, if we want to solve it, we would subtract 7 from both sides to cancel this out. And then we have negative 2v is less than negative 6. So we would divide by negative 2. And this time, the number we're dividing by is negative on the bottom. So we do need to flip our sign. And so we end up with v is greater than 3 because we had to flip it over. So now we're going to graph both of these together. Now the thing about or is the graphs are not connected. So this time the graphs should face separate directions. So we're going to put a dot on the negative 2, and it's going to be open because there's no bar underneath. And we're going to put a dot on the 3, and it's also going to be open. But this one is going to point to the left, and this one is going to point to the right in different directions because it's or, so they are not connected. All right, that's all for this lesson. And so if you guys would write your own summaries and bring those to class, then I will see you next time. Thanks.